Okay. So I tried to record myself doing this thing earlier. I forgot to turn on the microphone. So I'm gonna have to kind of, sort of, almost start over. So when I 3D print text, right? It's really, really hard. It's really hard to get to type words, right? And then get the 3D printer to produce those words. I mean, it's not that hard if you put the words on the side of the print. But if you put them on the top of the print, you get a bunch of little islands that are annoying to print and a bunch of retractions, and it gets messy. And if you put them on the bottom of the print, it screws up the first layer so bad that, like, oftentimes the print will fail. So I'm trying to solve that problem by designing a font to be easily 3D printable. And so what I did was I went and I downloaded this program called FontForge, and I made the letter A, the capital A, and as you can see here, it's in this here font. I don't know what that is. Anyways, so I've got the capital A, and I put it, and I installed the font into my computer, and I opened up Fusion, and I typed A and cut it out of a piece and 3D printed it, and I will just describe the end result. It was actually really good, but it had a few minor issues. The first problem, the most important problem, is that this hole here is too small for the size that I want this font to be printed at most of the time. I want to go in Fusion and size it at 5 millimeters because that's a good size, in my opinion. Right? That's a nice size for a font to be. At least a nice minimum size. So that's what I did, was I tested it at 5 millimeters, and then I printed it, and you could see everything but this hole in the middle when I printed it. So this hole needs to be bigger. And I can't just make the hole bigger because if I do that, well, for one, that happens because this program is weird. It likes to add curves because people who design fonts like curvy things. Anyways, I can't just make the hole bigger because if I just made a bigger hole, like this, then this distance here between these two lines is not going to be the correct distance, and it's not going to be the same distance as this distance here. And the way I want this font to work is when I cut this out of my piece, I want the letter to essentially be the tool path for the 3D printer, right? I want the extruder to draw the letter, essentially, right? And if I do this bigger hole, it can't quite draw the letter like that. It has to, like, do a bunch of crazy things, and that makes it harder to print. So that's the first problem. The second problem, which is the more annoying problem, is that when I make the font in Fusion be 5 millimeters, this whole square here, that will be 5 millimeters tall. From here to here in this program is 800 pixels. And from here to here and this bottom line here is the bottom of the letters, right? And from here to here is where the tail of a lowercase letter would go, like a lowercase y or a lowercase j, right? And when you start a new line, the bottom of the top line becomes the top of the underneath line, which means that if I were to type A, hit enter, and type A, I would get these A's touching each other, and that's not correct. That's not right. So I need to bring everything down some. So in order to do that, the only way I know how to precisely, the only way I know how to get the position of things precise is to get info on the points and edit the numbers for the coordinates. I'm going to bring this down by 200 and see what that looks like. And yeah, so because this whole thing has scaled down, and if this 800 millimeters was 5 millimeters, how tall will this 3 or 600, or if the 800 pixels was 5 millimeters, how many millimeters tall is the 600 pixels? It would be, hang on, I've got a calculator. I'm not going to use the calculator on the computer because I need to do some trigonometry for this to get, you know, the precise location of points. So I'm going to be using a calculator IRL, a really fancy calculator actually. Let's see. So if I have 800 over 5 is equal to 600 over what, then I get 800 to 5 is equal to 600 to another number. So I have to go 600 times 5 divided by 800 is 15 over 4. K times 1.0, 3.75 millimeters. Okay, so 600 is 3.75 millimeters. I don't like how short that is, because now this is 3 millimeters tall. But at the same time, an issue was, in order to make this hole bigger, I need to actually make the strokes thinner. I need to make all these lines. So what I had done earlier was I had assumed that the whole 1000 would be 5 millimeters, and so I did my math with that. I redid the math for 800, and 1.2 millimeters with 800 should be 160 pixels. So I'm gonna go up in my calculator's history and change some math real quick, because oh, my calculator doesn't have that. Okay. 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 I've got, so 1.2 Oh, apparently I didn't actually need to, Anyways. I need this, if this is going to be 3.75 millimeters, then I need this to not be 3 line widths of the nozzle. I need it to be 2. So it needs to be 0.8 millimeters. So I need to do some quick math real quick. I've got... So what I need to do is I need to figure out this angle here. And I need to do that only by using coordinates. And it's really annoying because I need to do trigonometry. Anyways, but the angle would be the arctangent of the y-coordinate of the top y-coordinate over the top x-coordinate minus the top bottom coordinate, right? That's just the whole SOHCAHTOA thing from high school, right? And then that gives me, let's see if I can draw this. That would give me a right triangle, right? That would give me this angle. I have this right triangle created by that angle. Created by these two coordinates, I have the right triangle. I can figure out that angle, right? That's fine. It's the arctangent of this distance over this distance. But then I need to figure out how far away this point needs to be from this point if this line, which is supposed to be touching this line, was perpendicular to this and 0.8 millimeters. So in order to do that, I've got another right triangle inside of it, right? Got another right triangle inside of it, and it looks like this, right? So this has to be parallel to this, and where this starts is defined by this, right? So I know that this is 0.8 millimeters, and that it's one leg of the right triangle, and what I'm looking for is the hypotenuse, and I know the angle of this, right? So if I have the opposite angle over the hypotenuse is equal to the sine of that angle, which I know, which is the arctangent of this, right? And I'm looking for, and I know that the opposite side is 0.8 millimeters. So now what I get is 0.8. The distance that these points have to be from each other is 0.8 over the sine of the arctangent of the y-coordinate, the top y-coordinate, over the difference in the x-coordinates. And that'll give me the length, and then I have to convert the length into pixels. So if I plug all that in, I get 0.8 over, I don't like this angle actually. I'm going to move this. That has to be 600, and then this is 100, I'll call it 200 and 40. Yeah, 240 looks good to me. So if I get 240 and 600, so I've got the sine, plugging this into my calculator, sine of the arctangent of 600 over 240 minus 100, because I know that this coordinate is 100. And I get that. And that is in millimeters. And so if I get 5 millimeters is to 800 pixels, then this number is to how many pixels? I have to multiply that by 800 and then divide by 5, and I get 131.4. I'll round down to 130 pixels. So this is 100, so move this to 230. And now this has to rise and run by the same angle. So that's easy enough, right? I will pick a y coordinate that looks good. How about 150? And if I had a rise of 600 to, what was it? 240, 100, so 140. And then I have a rise of 150 to some other number. Then 140 times 150 divided by 600 is 35. So this was at 230. So now this is at 265. And now these two lines are parallel, and they're about 0.8 millimeters apart from each other. All right. Get info. This one was 150. So this one is also 150. And then because these need to be 0.8 millimeters apart from each other, I need to move this point. And what is this? Can I delete that? Okay, I can. Okay. So instead of centering the A in the middle here like I did before, apparently it's actually best practice to line everything up to the left because of how kerning works. Kerning is like the spacing between letters. I'm learning a bunch of new things. Anyways, the difference between these two lines has to be 0.8 millimeters. And 0.8 millimeters is how many pixels? It was 5 millimeters to 800. So 0.8 times 800. And then divided by 5 is 128 pixels. Which makes sense because, yeah. So if this was 150, then this has to be 178. 278. All right. And this has to be collinear with this, so this has to be on the same angle, the same rise, same run. And because it was 128, right? The rise was 128, then the run is 29.8, so I'll call that 30 pixels. So get info, the x coordinate is 265. So get info 295. And then this y coordinate was 278. So this has to also be 278. And then this one has to be parallel to this. I need to find a good height. How does 450 look? I think, hang on. This was 600? Okay, 600 minus 128 is 472. Okay, so now if that's 472, that's a difference of 278. 194 pixels. Which translates to 45 pixels in the other direction. So this was 295 plus 45 is 340. Okay, so now I just gotta bring this over. 340, right? It was 45 pixels. So 385. So this one, 385. That's a bigger hole than before, but I don't necessarily like it. Let's see. Okay, let me think. Should I change it, or should I? Because when I bring everything over, it'll be pretty far to the right or to the left. The trouble is if I change the angle, I have to do that whole trigonometry thing again. But because like, the trigonometry will determine this distance, and this is what all the rest of these are based off of. Hang on, let me select all this. Okay. Get rid of that. Anyways, this was a 278 and 150. Oh wait, I can just, okay. This one was an X of 295 and 265, so that's a difference of 30. So this X was 385. This X? 385. So this would be 415. And then do the same thing on this side. The X is 265. Was that this one? Yeah, 265 and 230, so that's 35. This was 415. So 415 plus 35 is, plus 30, it would be 45, so 450. All right. And then the difference between these two X's is 230 and 100, which is 130. And this was 450. So this is 580. And then the difference between these two X's, 100 and 240. So this is 580 minus 240. Or no, 140. So 580 minus 140 would be 440, I believe. Yep. And so that is an A, I hope. So now what I can do is I can save this. I can generate, no. First, I need to look at the metrics. The metrics window is what lets me preview things. Whoops. Okay, so kerning. How do I do kerning now? Haha, that's not how that works. I don't know how to, What's funny is the black space is the positive space in this program, right? So this black stuff is what the program thinks the letter is. So if I were to cut it out of my piece, it would leave the A in it, but it would cut out the space around the A, which would mean that what's left is drawing the A. All right. So I can save this for now, and I can generate font. The convention, I don't care. Font contains errors, wrong direction, which is irrelevant. Direction determines whether something is whole or not, as far as I can tell. There are no holes in this. Non-integral coordinates, I don't know what the hell that means. Would you like, I'll just generate. So now if I, so I've got 3DP inverted stencil. Cool, cool. So now I can open my settings. Go to personalization, fonts, and just drag and drop this. Now if I open Fusion, it should see it as a font in there. Okay, so if I go to make a sketch, not on that plane, on this plane, and I make it about, I don't know, 10 by 10, whoops, by 20, and I make a text box. No, don't make a text box yet. Then I extrude this, not 2, 0.6. Now I make another sketch on here, and now I make a text box. and I make it 5, and I don't see it. Okay, so it looks like it's not going to show up if it doesn't start with a letter. So that's unfortunate. So I'm going to have to rename this. Element font info. I'm just going to name it all. I'm just going to name it inverted stencil. How about now? Okay, so now if I put this in my fonts folder, it might show up. Where's... Oh, there. Settings. Fonts. Okay, maybe that one will show up. It didn't go in there. Okay. And then if I do this, maybe it just didn't drag and drop. Let me see. No. Okay. Yeah, it just didn't show up in Fusion. So let me see if it shows up in Fusion. I'm learning a bunch of new things right now. It would be in the eyes. If it's inverted stencil 5A. Okay. Oh, then another thing, just to test. And then this is 15. Interesting. Interesting. The lines are overlapping. That's weird. Anyways, if I select this and I cut it out, can I cut it out? Okay. And I've got a bunch of letter A's, which is nice. And how much was this? 0.6? Make it 0.4. Okay. And if I make a sketch on here, can I measure the distance between these? Yes, I can, and it's 1. That's bigger than 0.8. What is this? 3/4 of a millimeter. That's pretty small, but what is this? 1.6 millimeters. That's pretty not small. After I get A done, after I'm satisfied that I can make an A, I think I'm gonna do lowercase f, because if I make a font real quick and I put a lowercase f, right? So I haven't made F, so it's just whatever was already in the default, right? If it can't find it in the, I assume that if the computer can't find a graphic for the letter in your font, it'll just use the computer's default font. The problem with F is if I rotate this, can I rotate this? Okay. The problem with F is that it can come up here and connect to the outside like that, but then it's got these sticky outy bits, and those are not nice to print. So I might have to make sticky outy bits shaped like that, right? And then for F, it would be, so for F it would look something like that, which would be funny, but it looks F enough, so. Doesn't it? Yeah. Anyways. I'm going to keep Control-Zing until there's no more F. Okay. So I'm going to go ahead and rename the body to A. And then I'm going to save it, and it is in 3D printing font tests, save. Hopefully the letters will be able to be read. So now I'm gonna slice this model and print it and hopefully be able to read the letter A. And if I can read the letter A, I'll move on to F. I'm going to try to make F look like it should look. And if I can't get that to work, then I'll make it with sticky outy bit, or with pointy bits, which is pretty funny. Yeah, a lot of coughing today. But yeah, for now, oh, you know what? I don't want this to peel up because I'm not testing anything. I'm only testing whether, I only want to test this part. So I need to round off these edges real quick. Okay, now I can save it. Yes, replace it. There. Because if there were sharp corners, then it increases the likelihood that it's going to peel off of the printer. And like, that's not a big issue with something as small as this, but better safe than sorry, you know? So, gonna go ahead and print this out, see how readable it is. Then I'm gonna figure out what the heck is the issue with the because if I measure this line, how big is that? That's 5 millimeters. Okay. So the way it works with the text boxes then is if I made it 3 millimeters and typed A. Oops. and I cut this out. And then I also decided to hit Enter A. Now if I make a sketch here, what's that? That's 3 millimeters. So then this would be 0.633. Okay. Interesting, interesting. You know what? I'm going to go ahead and save this too. I'm going to test that too. Whoops, no, don't rename it. Yes, replace it. Okay. Now I'm going to print it out and see how well this works. I'd like to see what this does, because like strangely it seems like the computer, like the program here, is deciding the size of the lines, which whatever, you know, I guess, but I'm gonna see how well I'm gonna see if I can read the letter A. 5 millimeters is what I intend to use mostly anyways. So hopefully these will be readable. If these are readable, then I'll make everything the same height as this and do all the letters like that. So yeah. Now I'll go ahead and print this out. Okay. I printed out my little A's. You can see the holes at the bottom of each and every single one of these, but the only one that has a hole in the middle is that one, and it's barely visible. I'm not sure what to do about this, because when I tested the other A's that I failed to record properly, they had the same issue. So, and what I thought would solve it ended up not solving it. I did make the A thinner, so probably when the hole got bigger in one direction, it got smaller in the other. I think an easier thing for me to do, though, would be to not have any holes in any of my letters, which would really hurt some of the letters. I'm trying to think which letters have holes in them. Do you want to rub on this, Una? Yeah, she wants to rub on this. Cats like these little sharp objects. Okay, so I'm going to go ahead and draw out the alphabet here. First in capitals. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. A is one of the ones with holes. B has a hole in it. D, O, P, Q, R. Okay. A, B, D, O, P, Q, R. That's 7 letters, have holes in them. So what does it look like if I fill that in? And then the A would be Then the B would be D would be Q. R. O obviously would be. I think those can be. I think if you were to see that in the context of the other letters, you would be able to tell that that was supposed to be that those each of those is supposed to be their corresponding letters. But what about lowercase? A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Now the trouble letters are going to be here. A, B, C, let's see, D, E. G, I think for I want to try something. If I have, no, that's not going to work. Okay, what else we got? O, P. Again, P is the same, probably going to be the same letter, but smaller and lower down. Q. If I can get a curve in the Q, that would do that. And then R doesn't have, lowercase r doesn't have a hole. Right, so ignore that I. I've got 1, 2, 3, 4, 5, 6, 7 letters in both upper and lower case, or in each, has, okay, F. Right, I'd have to do something like that, and that's kind of annoying. Right? That's not too bad looking. Lowercase f. This is going to be a weird font. This is going to be such a weird font. But I think the best bet is to just go without any holes. You know, I think that's the best bet here. Because holes are a problem. Holes are a problem anyways with regular fonts, right? They're one of the reasons why a regular font doesn't work too well. So I'm going to have to think hard on the rules of this font in order to make it printable and cohesive. That's one of the challenges of designing fonts is rules to make the letters work together and be cohesive, you know? They need to have consistent rules for how letters should look. So I'm going to have to figure something out for that. I will give it some thought. But this is going to be tough because this is graphic design for the purposes of manufacturing or something. Like it's manufacturable graphic design or something. It's not what I'm used to. So this is going to be tough. And the tiny A's were so tiny that there isn't even a stick here to hold them up. So I think the solution for that is just hit enter twice. Because let me look at the, yeah, this one. It looks best if you hit enter twice. This is 2.5 millimeters tall. And they're separated by an entire line between them. This is 5 millimeters tall, and they're separated. They're just one line after the other. So I think hitting enter twice is the best way to go if you want to make stuff like that. But also, typically, when putting text in prints, it's like 1 or 2 words. So like you're never gonna need. So like I gotta also think about when am I gonna need that. You know, I think that's not too bad of an issue. At least for me, it's just 1 or 2 words when I put text in prints. So yeah, I'm gonna think on designing some the design of this font to make it printable, but that's why f is lowercase f is a problem child. Lowercase f is a problem child, and then another one is s. S is a problem because if this was the box, the S has to touch the box. And if I do a curve like that, that's kind of an S. But to make it look more like an S, these curves have to come up. Same with J. I wonder if J, though, can just be kind of a backwards L, but with a curved bottom. And all of these have to be consistent with each other too, you know? It's an interesting challenge. So I'll have to get to work on the design of these letters.